Welcome everyone to the Airscout Flow Meter launch presentation. We've been preparing for these products for prime time for much of the year, and we're excited to finally be here with all of you today. With that, we'll go ahead and dive into the training. It's widely known that compressed air is the most expensive utility, but surprisingly, unlike electricity, water, or gas, its consumption usually isn't measured or monitored in any way. Throughout this training, we'll review the ISO standards for energy management and conservation, identify the issues behind unmeasured compressed air, explore the values of using flow meters as a solution, and define the Airscout flow meter product line, as well as clarify some of the installation guidelines and connectivity options. Many of you are already seeing an increased awareness of energy usage and interest in efficiency improvement. ISO 50001 is a voluntary international standard developed by the ISO organization, which helps provide organizations with management strategies, and it helps increase energy efficiency, reduce costs, and improve energy performance. ISO 11011 from 2013 sets requirements for conducting and reporting the results of a compressed air system assessment, and it takes into consideration the entire system from the supply side down to the demand side. Many facilities have at least a general understanding of how much air they're producing, but many haven't explored how much is actually used or wasted. Air compressors consume a great deal of energy in the form of electricity, and for this reason it's important for companies to accurately measure and audit compressed air usage and efficiencies. A typical plant that hasn't been well maintained will likely have a leak rate of about 15 to 20% of total compressed air production capacity, and this combined with the misuse and artificial demand results in only about 50% of air being used for normal production. All facilities utilizing compressed air systems should strive to establish and maintain compressed air leak monitoring and repair programs. Regular surveys are important to identify opportunities for improvement and provide consideration to changes in plant configuration which may have been resulted in additional inefficiencies. And then once those repairs are made, plants will continue to benefit from those energy savings. With compressed air being the most expensive utility, measuring, monitoring, and acting on the results provided by the flow meters is exactly why companies will consider their installation. Many companies use flow meters to determine usage by the department or even a process, and distribution of air among different parts of a campus or a facility relies on efficient operations to successfully reduce the energy costs. And this can only be accomplished with accurate measurement instruments. There are a wide variety of measurement principles utilized in flow meter technologies today. To choose an appropriate flow meter, there's a number of factors to consider, including the system range, technology cost, accuracy, the equipment's ability to measure multiple parameters, pressure loss, and maintenance requirements. While growing in popularity because of their lower maintenance requirements, ultrasonic flow meters like the Airscout tend to be more expensive and require multiple units to measure additional parameters such as flow, pressure, or temperature. While Ingersoll-Rand's demand-side flow meters utilize the thermal mass flow principle, which offers excellent specifications in all these areas, and only one unit is required to measure flow, pressure, and temperature. All of Ingersoll-Rand flow meters come standard with bidirectional flow measurement capability. This allows for accurate measurement of the total air consumed, and by using a heater on a Wheatstone bridge, the flow meters are able to determine flow by the air passing over the sensor system. As the air on one side of the sensor system cools down, the direction is determined. The degree at which the temperature drops determines the amount of flow. The sensor uses a solid-state silicon design, and it's important to point out that while this is different from silicone, we definitely want to avoid that silicone. Bidirectional flow is ideal for ring networks and in systems with larger receiver tanks. As air flows through the ring network or back into the larger receiver tank, the bidirectional capability utilizes a totalizer function, and that helps gather the air actually consumed rather than just passing through the flow meter sensor. In this illustration here, the airflow is entering into the ring network. And then in the second illustration, the compressor is off, the demand is low, and air is returning back into the receiver. The flow meters are totaling up the flow by subtracting the air that's originally passed through the flow meter, but now it's entering back into storage. The Airscout flow meters consist of a comprehensive product line with capabilities to measure multiple parameters including the flow, pressure, and temperature, as well as that total air consumption. The Airscout product line is designed for use with inert gases including air, nitrogen, argon, carbon dioxide, helium, and other non-flammable mixtures. Product technologies are also available for both the wet, untreated air of the supply side, as well as the clean, dry air of the demand side. The Airscout Insertion probe is the most popular flow meter in the product line, and it's designed to measure in applications with pipe diameters 2 inches and larger. The Airscout Insertion Probe DP is very similar to the standard insertion probe in that it's designed to measure in those applications 2 inches and larger pipes, but it's designed for use in the wet, untreated air of the supply side. Then we have the Airscout Inline, which is ideal for use near each point of use equipment or tool, and it's available in 1/2 inch, 1 inch, and 2 inch sizes. The Airscout Terminal is an accessory option to provide digital readouts of results in an easily accessible location, and it's ideal when flow meters may be out of sight or out of reach. Getting into the details with each of the products, the Airscout Insertion Probe is a 400 mm probe with the capabilities to measure mass flow, pressure, temperature, along with that bidirectional flow measurement as a standard feature. There's also a 600 mm probe that's available for larger pipe installations. To communicate out these readings, the flow meter can connect to either a digital display with 2 million data point logger or a connector cap. The digital RS-485 Modbus is available to view all 3 parameters, and then an analog 4 to 20 milliamp pulse is available for switchable outputs. This product's ideal for demand-side measurements, whether it be temporary installation with air audits or permanent installation as part of a leak management or energy efficiency type program. The Airscout Insertion Probe DP is also a 400 mm probe with the capabilities to measure mass flow, pressure, and temperature, along with bidirectional flow measurement as a standard feature. The same digital display with 2 million data point logger or a connector cap with the digital and analog communication options can be used with the probe. The DP probe sensor has an extreme resistance to pollution and water, which is ideal for supply-side measurement, whether it be temporary installation with air audits or that permanent installation. The Airscout Inline is available in 1/2 inch, 1 inch, and 2 inch options with the same capabilities and communication abilities as the probe-style flow meters. The inline flow meters all come with inlet and outlet tubing and are available with a built-in display and 2 million data point logger or no display or data logger. The display and data logger option also has a micro USB to USB port for direct connectivity into a computer for download of data for analysis. This product is ideal for the demand-side measurement with permanent installation. Most commonly, it's going to be used near the point of use, but also in some smaller systems. The Airscout Terminal is a wall-mount display with the same functionality as the point-of-use displays and includes a 2 million data point logger, as well as a micro USB to USB port for direct connectivity to a computer for download data for analysis. The terminal includes a 30-foot connector cable and a 6-foot power cable for use when needed when it's not being hardwired into a system. An Airscout terminal would ideally be needed for each flow meter that requires a wall mount display, and the terminal is ideal when the display can't be read at the point of use or when the installation of the flow meter may face a wall. The Airscout Studio is a configuration tool for setting up operating parameters. The Airscout Studio is capable of configuring any insertion probe with or without a display. The Airscout Studio also could be connected in the flow meters to download recorded data points for analysis. Real-time measurement readouts available for all the flow meters with the purchase of a license key. And as I previously mentioned, the Airscout Inline with display and data logger, as well as the Airscout Terminal, have a micro USB to USB connectivity, and that's for connection into a computer and the Airscout Studio software. All the other flow meter probes will require an interface box to convert the RS-485 signal. The Airscout Starter Kit is the perfect initial purchase for auditing or a customer's permanent installation. The kit includes a 400 mm probe, the display with data logger, power supply, safety chain, and compression fitting. It also includes a license key for the Airscout Studio, as well as the interface box for connectivity of the probe into the computer. Other recommended parts to install the flow meter are a saddle clamp and a 1/2 inch male to female ball valve. There's a hard case that we also have available as a separate option, whether it be for auditing or temporary installations, which is ideal when transporting the probes or when storing them. When developing recommendations to a customer for flow meter installation, it's important to consider how and where the data is going to be viewed. The point-of-use display and data loggers, as well as the wall-mount terminal, all display current conditions, but data analysis capability is only available on the Airscout Studio. If an X-Series controller's I/O box is available, the flow meter can be wired into the display through a 4 to 20 milliamp signal, but it will show only one parameter. The I/O box also can't perform that initial setup of the flow meter. As I mentioned, there's two connector caps available for the insertion probes, an M12 5-pin and an 8-pin. The 8-pin is designed for connectivity into the Airscout terminal, and all the other readout devices, including an I/O box or a computer, to the Airscout Studio require a 5-pin. All replacement parts have already been established and are orderable in Oracle in case anything were to break or get lost. These parts are listed in the user manuals as well as the technical and marketing notes. That concludes the product portion of the presentation. With that, I'll pass it over to Chris Gibson to discuss the installation and connectivity options of the product.
Okay, as David mentioned, we'll discuss some installation tips that you might need to be aware of when speccing out a flow meter. Paying careful attention to the initial setup of each flow meter is critical to ensuring accurate readout of system measurements. Knowing the exact inner pipe diameter for input into the Airscout Studio will drive this accuracy. The flow meter's internal pipe size calibration is based on a calculation of internal area of the pipe with other variables including airflow speed, temperature, and pressure. Entering the wrong pipe diameter, even as little as 2% error, can lead to more significant deviations in readout results. When using a data logger, the interval at which the data will be recorded needs to be set, with options ranging from every second to every 5 minutes. Setting the 2 million data point logger to record once per second for all parameters will allow for more than 1 week of recorded data. Sessions can also be started and stopped to measure specific system events, and can be reviewed or removed independently of one another. When using the Airscout Studio to set the recording intervals, an estimated total available length of time will be displayed based on the system memory. Choosing the correct installation location is another important aspect to consider as part of the recommendation process. The flow meter should have access to the power supply and be readily accessible for maintenance and data readout. Insertion probes should be installed at least at an angle of 15 degrees upwards or greater. Careful attention should also be made to avoid installing closely after a bend or pipe junction, excessive heat on the unit or in direct sunlight, potential water damage or corrosive elements external to the pipe, electrical problems as a result of high voltage and excessive vibration from walking bridges, vehicles, and process equipment. Compressed air passing through a regenerative dryer or other heat source has a tendency to elevate the temperature, which can affect the accuracy of the flow meter. Installation of the flow meter further downstream from this type of equipment will assure that the air has cooled sufficiently for accurate measurement. As compressed air flows through a piping system, headers, elbows, and reductions and enlargements can all have an effect on the flow profile. A minimum distance both before and after these pipe transitions should be observed to ensure accurate measurements. Recommended upstream and downstream lengths of pipe are made based on these various pipe transitions, calculated by the number of lengths of inner pipe diameter. For example, a change in diameter from small to large in a 6-inch header pipe would recommend 40 lengths upstream and 5 lengths downstream. The 40 lengths of 6-inch pipe equates to 240 inches or 12 feet upstream and 30 inches downstream. Airscout inlines come standard with inlet and outlet piping. These accessories are typically all that is required to obtain accurate measurements. No additional length of pipe from transition point is typically needed. The example seen here shows the reaction a pipe transition has on the compressed air's flow profile. This double elbow results in a swirl pattern which causes the air to travel at different speeds until it is able to return to normal uniformity. In this example, with a double elbow, we can expect the flow profile to return to normal after 40 links of pipe and would recommend 10 links after the flow meter. If the pipe's inner diameter is 58 millimeters, the distance of installation after the double elbow would be 2,357 millimeters, or about 8 feet, and 1.5 to 2 feet after the flow meter. In many cases, when installing an insertion probe flow meter, a saddle clamp will be the preferred method for installation. To successfully install, ensure a 3/4 inch hole is created. The insertion probe is 1/2 inch wide, which allows for extra room in case the saddle adjusts slightly. It is also recommended that a 1/2 inch male to female ball valve be connected to the saddle, allowing for the orifice to be closed when the insertion probe is removed from the pipe. A 1/2 inch compression fitting is included with the flow meter assemblies and is fitted to the ball valve. In the compression fitting, Teflon ferrules are used to prevent damage to the flow meter when being removed or reinstalled. It's critical to always use a safety chain as well with an insertion probe. All this information is available in the user's manual, which should be very carefully reviewed before installing the flow meters. When installing an inline flow meter, the existing piping should be removed and replaced with the inline flow meter's inlet and outlet tubing. The stainless steel tubing supplied with the flow meters offer a uniquely smooth transition to the inline fitting. Many times the connection of the inline fitting directly to the standard threaded pipe fitting causes the flow profile to be distorted, potentially affecting the readout results. All Airscout inline fittings are BSP threaded, but with the use of the inlet and outlet tubing, the male ends inserted into the fitting are BSP, but the male ends that will connect to the simpler type pipe fittings are NPT. Both the Airscout insertion probe and inline flow meters can be connected to the X series controller via an I/O box using a 4 to 20 milliamp analog input. As seen in the internal I/O box pictures here, there are two parts to the connection, which are the power supply wires and the communication wires. There are three 24-volt DC terminals available on the PSU-24 and 4 analog input signals available. Once the wiring is complete, the analog input can be properly scaled to provide the proper operation. The I/O box can provide instructions on how to input these values. Transitioning over to consideration for flow meters that have been installed for a period of time, cleaning of the sensors may be required and is largely dependent on the level of contaminants in the airstream. It is recommended to clean the flow meter probe and display connector cap with a mixture of demineralized water and rubbing alcohol along with a new microfiber cloth, removing built-up residue. Insertion probe sensors can be cleaned by being dipped into a mixture of lukewarm demineralized water and non-aggressive cleaner, then removing the tip through the water, but pay careful attention not to bang the sensors into the container walls. Inline sensors can be cleaned by using a cotton swab with the same lukewarm demineralized water and non-aggressive cleaning mixture, gently cleaning the sensors. While recalibration of the flow meters are all based on time and service, cleaning is based on the cleanliness of the airstream. A visual inspection of the flow meter and sensor can be done to determine cleanliness. Recalibration of all Airscout flow meters is recommended on an annual basis. Ingersoll Rand has developed a recalibration program with stock of recalibrated flow meters at the DLC as part of an exchange program. The recalibration date can be found on the Airscout Studio for each unit. Once a recalibrated flow meter is placed into a system, be sure to reset the inner pipe diameter settings. Additional details on the flow meter recalibration process are available on the Services SharePoint site or contact Services Marketing at the email listed on the slide. Here you will find a suggested process in how to successfully sell the Airscout flow meters to a customer. The first step is to identify potential customers. Typically customers who will have the greatest interest are moderate to large customers with aging compressed air system or system with numerous compressor sizes. Also, aging piping systems increase the likelihood for leaks, opening the opportunity for leak management benefits. Once a customer is identified, you'll want to start understanding their goals to make more educated recommendations. Leak management, energy efficiency, and cost allocation are the biggest drivers for flow meter installations. After clarifying the customer's goals, the next step is to put together the equipment needed to achieve these results. Flow meter locations, pipe sizes, and computer connectivity should all be taken into consideration. When sharing your product recommendation to the customer, you'll want to review the value of the product offering again and discuss potential actionable improvements to expect. Finally, as a service to your customer, in addition to regular equipment maintenance, be sure those flow meters installed are being recalibrated annually. A number of resources are available to further educate and understand the Airscout flow meter product line. The selection tool is a wonderful addition to our technical resource offering and is designed to assist the field in identifying necessary CCNs to be ordered based on the customer's requirements. We've also created a comprehensive technical marketing notes document that serves as a supplement to the user manuals for product line. In addition to those technical resources, a new brochure has been created as well. And I'm Chris Gibson, North America Marketing Specialist, pre-sale support for all accessories. If you have any questions, you can contact me at the email listed on the slide. Thanks for your time.